Hello students, now let us study the monostable multivibrator using IC555. We know that IC555 can be used in three different types of modes: stable multivibrator, monostable multivibrator, and bistable multivibrator. So today we will study the monostable operation or monostable multivibrator by using IC555. So this is the circuit diagram of monostable multivibrator using IC555. Here in this circuit, pin number 6 and 7 are connected together. Then pin number 4 and 8 are also connected together. So pin number 7 means it is a discharge pin. The external capacitor discharges through pin number 7, that is uh, through the internal discharge transistor. Okay. Then pin number 6, it is a threshold pin. It is a threshold pin or threshold input of upper comparator. So pin number 6 and 7 are connected together. Pin number 4 and pin number 8, these two pins are also connected together and connected to plus VCC. Pin number 3, it is the output pin. So we take the output from pin number 3. Okay. Pin number 1, it is a ground pin. It is connected to the negative terminal of the DC power supply. Pin number 8, it is a plus VCC pin. So it is connected to positive terminal of the power supply. Pin number 4, it is a reset pin. So here we do not require this facility, that is a reset facility. So this pin number 4, it is connected to plus VCC. And pin number 5, it is connected to ground through a small value of capacitor, normally 0.1 microfarad or 0.01 microfarad. This capacitor is used to filter the external noise and to keep the 2/3 VCC constant, to keep the control voltage 2/3 VCC constant. So for this purpose, a small value of capacitor is connected to pin number 5. Okay. Now pin number 2, it is a trigger pin. Actually it is the trigger input of the lower comparator. Trigger input of the lower comparator. So when trigger input is applied, then output at pin number 3 goes high. Before applying the trigger, the output is low. Okay. Now monostable means, mono means one. This circuit has one stable state, that is low state. So whenever we are not applying trigger input, the output remains stable state, that is at low state. But when trigger pulse is applied or when trigger input is applied, then this state changes to unstable state, that is from low state to high state. Okay. So this mono means one. This monostable multivibrator has only one state stable, that is low state. It is a stable state, and it becomes to unstable state or it changes to unstable state when trigger input is applied. Okay. Now see the working of the circuit. Here, before applying the trigger input to pin number 2, before applying the trigger to pin number 2, the trigger pin voltage at pin number 2 is above 1/3 VCC. The voltage at pin number 2, that is trigger input, is above 1/3 VCC because R1 is connected to pin number 2 and it is connected to plus VCC. Therefore, before applying trigger, the trigger input voltage is above 1/3 VCC. Therefore, the output at pin number 3 is low and LED is in the off state. The LED is in the off state. Also, the external timing capacitor C, it is held in the discharge condition. The external capacitor C is held in the discharge condition, because as the capacitor C charges, voltage across it increases exponentially, and when it reaches to two-third VCC, then the pin number 6 is also connected here. So pin number 6 means it is a threshold input of upper comparator. So upper comparator activates, its output becomes high, and it drives the discharge transistor. So internal discharge transistor will be in the saturation condition or on condition. Therefore this external capacitor discharges through the internal transistor. Therefore, this external capacitor C is held in the discharge condition, because when VCC supply is when VCC is turned on, then the capacitor C charges through resistance R, and during the charging period of the capacitor, voltage across it increases exponentially, and when it reaches to two-third VCC, then this voltage to two-third VCC is applied to pin number 6, where it is a threshold input of upper comparator, and it changes, its output becomes high, and it sets the flip-flop. Therefore Q is equal to 1. Therefore the internal transistor is turned on, and therefore it acts as a closed switch, and it provides path for this capacitor to discharge through the transistor. Therefore this external capacitor C is held in the discharge condition. Okay, it discharges through the internal discharge transistor, that is through pin number 7. Now see, when trigger input is applied, that is when push button is pushed, then pin number 2 is connected to ground for a short time. That is, pin number 2 is connected to ground for a short time, means the voltage trigger input becomes 0 volt. Trigger input voltage becomes 0 volt, and since it is a 0 volt, it is less than one-third VCC. So lower comparator has two inputs. One is a trigger input, and other input has reference voltage one-third VCC. Therefore, since the trigger input voltage is 0 volt, it is less than one-third VCC. It is less than one-third VCC. Lower comparator compares this 0 volt with one-third VCC. Therefore, the output of lower comparator goes high, and it resets the flip-flop. So since RS flip-flop resets, then Q bar is equal to 1. That Q bar means output of pin number 3. Therefore output at pin number 3 goes high, and therefore the LED glows. Okay, so output becomes high and the LED glows. Now this on time of LED, that is time for which this LED is on, it depends upon the RC time constant. If R is large, then capacitor takes longer time to charge and to reach up to two-third VCC. Okay. Now, since Q bar is equal to 1, at the same time Q is equal to 0. Since Q bar is equal to 1, at the same time Q is equal to 0. Therefore, as Q is equal to 0, therefore the internal discharge transistor is in the cutoff condition, because Q is equal to 0, and the internal discharge transistor is NPN type. Therefore the transistor is in the cutoff state, and it allows this capacitor C to charge through this series resistance R. Now, as the capacitor C charges through resistance R, voltage across it increases exponentially. Now, when this voltage across the capacitor reaches to reaches to two-third VCC or above two-third VCC, then the upper comparator's output goes high. This voltage is applied to pin number 6, that is it is the threshold input of upper comparator. Therefore, the output of upper comparator goes high, which sets the flip-flop. And therefore, hence, as it sets the flip-flop, then Q is equal to 1 and Q bar is equal to 0. Now, Q bar means the output of pin number 3, and therefore the output goes low and the LED remains off. Okay. Now, since output is low, then at the same time Q is equal to 1, and therefore the internal discharge transistor is in the saturation state. It is in the saturation state because Q is equal to 1. Therefore, the internal transistor is in the saturation state. It acts as a closed switch. Therefore, it provides path for this external capacitor C to discharge through it. Therefore, the capacitor discharges through the transistor. Okay. Now, when the next trigger pulse push button is again pushed, then again the trigger input goes low, or it becomes less than 1/3 VCC, or trigger input voltage is 0 volt, it is less than 1/3 VCC. Again, as it is less than 1/3 VCC, then lower comparator has high output which resets the flip-flop. Therefore, as the lower comparator's output goes high, it resets the flip-flop. Then again Q bar is equal to 1. Therefore, the output at pin number 3 goes high, because pin number 3 means Q bar output. So the LED again glows, and this on time of LED depends upon the RC time constant. This time delay of the circuit is given by the equation T is equal to 1.1 RC. See the waveform. Here, when trigger pulse is applied to pin number 2, then at the same time the output at pin number 3 goes high. And it remains in the high state whenever the voltage across the capacitor is less than 2/3 VCC. When the voltage across the capacitor reaches to 2/3 VCC, then the output goes low. So this is the waveform, and this is the circuit diagram of monostable multivibrator using IC555. The time delay T is equal to 1.1 RC. This is the waveform, that it is the trigger pulse. It is applied to pin number 2. It is the output waveform. This time delay T, it depends upon RC time constant, and if R is more, then time is also more. If C is more, or C is large, capacitance is large, then also the time delay will be large. If R is small, then time interval decreases, or when C is small, again the time interval decreases. Therefore, this time delay depends upon the value of R and value of C, and it is given by the equation time delay T is equal to 1.1 R into C. Okay, so we will stop here.